Okay, in this video we are going to talk about why the limit as x approaches infinity of the quantity 1 plus 1 over x to the x is equal to e. And it actually illustrates a technique that you use kind of frequently when you're finding limits, so it's a good problem to do overall. So we're starting with this, and if you were to try to do direct substitution, whatever that really means with infinity, you would end up with 1 to the infinity, which we're not really sure what that is. That's kind of indeterminate. So the technique we're going to use is we're going to start off by just letting y equal the thing we're taking the limit of, right? So all I'm doing is saying y equals and that thing, so 1 plus 1 over x all to the x. And so that means really that I'm looking at the limit as x approaches infinity of y, which is still equal to the limit as x approaches infinity of 1 plus 1 over x to the x. So it seems like I haven't really done anything yet, but I can do a lot of stuff to y. So what I'm going to do, it's not really obvious why I'm doing this to begin with, is I'm going to take the natural log of both sides of this. So that gives me that, and they're still equivalent. And then I'm also going to use the property that exponents become coefficients. So natural log of y is actually x times natural log of the quantity 1 plus 1 over x. Okay, and so that means that if I take the limit of this equation that I just wrote here, I can work with that. So that's what I'm going to do. So I've essentially taken the natural log of both sides of my original limit equation. So I've replaced y with natural log of y. I've replaced the quantity 1 plus 1 over x to the x with essentially the natural log of 1 plus 1 over x to the x, except I use the property that exponents become coefficients. So now I have this limit, and this limit, the limit on the right is what you want to worry about. So the limit is x approaches infinity of x times natural log of 1 plus 1 over x. If you just direct substitute in there, you now have infinity times 0, which is still almost indeterminate. It's kind of almost something we could use L'Hopital's on, but not quite. But there's a trick you can use to always turn this into something that you can use L'Hopital's on, and that is to invert one of the things. So what I'm going to do is I'm going to invert the x. So it becomes natural log of 1 plus 1 over x, and then all that is over 1 over x. So if you algebraically simplify that, it goes back to what you had in the previous step. So they're equivalent, but the nice thing about this is if I go to infinity, I get 0 over 0, which means I can now apply L'Hopital's rule. So that's what I'm going to do. So I'm going to copy this to the next page and keep going. Okay, so this is what we had. And now I know that I have 0 over 0 on the right-hand side, so I'm going to use L'Hopital's rule on that. So we're going to L'Hopital's this. So that means it's the limit as x approaches infinity of, so the derivative of the top is 1 over u, where u is 1 plus 1 over x, so 1 over u, plus the derivative of u, which is negative 1 over x squared. It's easiest if you make that x to the negative first and then just kind of power rule it. And then all of that is over the derivative of the bottom, which is negative 1 over x squared. And this is good, right? Because I have negative 1 over x squared in the numerator and the denominator. So there and there, so I can actually just cancel those. And now if I take this limit, it's going to give me 1 over 1 plus 0, so it's going to just give me 1. All right, so I figured out that the limit as x approaches infinity of the natural log of y is equal to 1. So let me copy that. So a thing that I like to do here is I like to move the limit inside the natural log. I feel like it's just a little clearer what we're doing. You can do that because natural log is a continuous function, so you can move the limit in or take it out. I moved it in, obviously. And now I'm going to exponentiate, right? If the natural log of something is equal to 1, that means that e to the 1 is equal to that something. So the limit as x approaches infinity of y is equal to e to the first. And then if you remember, y we originally said equal to the quantity 1 plus 1 over x to the x. So we've shown that the limit as x approaches infinity of 1 plus 1 over x to the x is equal to e. This is a really important limit. It's well worth your time to memorize it. It doesn't take very long. It shows up a lot. The technique that we use is also pretty important and will show up frequently when you're using L'Hopital's rule. So I hope you found this helpful, and good luck.